Hello students, today we are going to see some more interesting and important questions from Narendra Avasthi sir's physical chemistry, mole concept. Come on, let us discuss few more questions from this session. Here the first question, 0.2 mole of HCl and 0.2 mole of barium chloride are dissolved in water to produce 500 ml solution. The molarity of Cl minus ion is. Okay, now come on, let us identify the answer. So first and foremost, let us identify all the data so that it will be easy for us to calculate it. Okay, so the mole of HCl, the mole of HCl, the mole of HCl, how much? 0.2 mole. And the same way, mole of barium chloride, mole of barium chloride, BaCl2, how much? This also they mentioned 0.2 mole. Okay, now volume of the solution. Okay, water produced 500 ml solution. Volume of the solution. Volume of the solution. Solution. How much it is? 500 ml. Right, now here we have to find out the molarity of the solution. So, molarity of Cl minus ion. How much? That is the question. Right, now here when we write the equation, that easily we can identify what are the moles from Cl minus. Right, now here H plus, so HCl, when we separate it, H plus Cl minus. Now HCl, how many moles are there? Here 0.2 mole. Okay, so HCl, how much mole? It is 0.2 mole. Right. Enter here, how many mole you got it? Here only 1 mole. Right. Okay. Now the next one, BaCl2, when we separate it. BaCl2, when we separate, Ba2 plus plus 2Cl minus ion. I hope you got that idea. Okay, now here also BaCl2, how many mole? It is 0.2 mole only. And Cl minus ion, how many? Here 2 mole. 2 mole of Cl minus ion. Here also Cl minus ion. Right, now here you will get how much? Here you will get 0.2 mole of chloride ion. And the same way here you will get 2 into 0.2. So that means 0.4 mole. Right, so here 0.2 mole of Cl minus, and the same way here 0.4 mole of Cl minus ion. Now total moles, right, now let us identify the total moles. So the total moles of Cl minus ion, how much it is? 0.2 plus 0.4. Together you will get how much? 0.6 moles. Right, Cl minus ion moles, it is 0.6. You got it. Now the next one, volume of the solution. Okay, volume of the solution already we mentioned in that data, right? So volume of the solution, how much? It is 500 ml. So make it 1 liter wise. So that means 500 ml divided by 1000 ml. So you will get 0.5 liters. Right, I got it. Now next one here, molarity we have to identify. Molarity. So molarity equal to what it is? Number of moles of solute divided by volume of solution in liter. So moles by volume in liter. So that means moles, how much? Cl minus ion only they are asking. So that means 0.6 moles. You know how do we got that 0.6 moles? Divided by, and volume in liter, it is how much we got it? 0.5. Right, 0.5 liter. Right, now here what is the molarity you are getting? Molarity equal to, you will get 1.2 molarity. Right, so molarity of Cl minus ion, the molarity of Cl minus ion, that is actually 1.2 molarity, or 1.2 mole per liter. Right, we can mention this way also, because molarity is nothing, mole per liter only we can identify. I hope you got the clarity. How do we identify? Generally, if they are asking like only one ion from that solution, easily you can identify through this point. That is what purposely I mentioned in that. So this will be, I think you are able to understand. Yes, come on. Which is the correct option here? The correct option, yes, here the option it is C is the correct option. I hope you got the clarity. Come on, let's go to the next question. The next question, calculate the mass of anhydrous HCl in 10 ml of concentrated HCl density. It is actually 1.2 gram per ml solution having 37% of HCl by mass. Right, now come on, let us check the mass of anhydrous HCl in 10 ml of concentrated HCl solution. Right, now they have given density equal to what it is? Mass by volume. So they have given 1.2 gram per ml. Right, now here volume of HCl, volume of HCl, volume of HCl, it is 10 ml. Right, now density, it is actually 1.2 gram per ml. Right, now here mass of HCl, that is mass of anhydrous solution. So mass of anhydrous of HCl. That means there is no water, anhydrous means, right? So this is 37% by mass. So 37% by mass means we can make it, right? Now here density they have given. So density equal to density equal to mass by volume, right? Now density, how much they have given? It is 1.2 gram per ml, right? Now here mass of the solution. So mass of, now all the data we collected, now we can apply the value over here. So mass of the solution, how much here? Generally mass of the solution, how can we identify? Density equal to mass by volume. So now M equal to D into V, that means density into volume, right? So volume in liter into density. So can you apply the value over here? So here how much you can apply? Volume, it is liter only, but here ml they have given, let it be ml only. So 10 ml, which is very less, so into density 1.2 gram per ml. Okay, here also they have given ml, so let it be there as it is. So ml will be cancelled. So how much it will be? Around 12 gram. So mass of the solution, it is 12 gram. Mass of the solution of HCl, right? Mass of anhydrous HCl, right? So mass of the solution, this is HCl. Mass of anhydrous HCl. That is, they have given the percentage. That is what purposely I am just mentioning. So percentage, mass of the solution into percentage, right? So mass of the solution, how much? Just now we found that is actually 12 gram into percentage, how much? It is 37%. So 37 by 100. I hope you got the clarity. Now, when you calculate this, 12 gram into 0.37. So you will get 4.44 gram. So mass of anhydrous HCl. It is actually very simple and it is very easiest question. So mass of anhydrous HCl, how much? It is 4.44 gram, right? Sometimes we can convert into liter, but sometimes if it is very less, directly we can go by ml only. And see, mass of the solution, mass of anhydrous, how much percentage they have given. See, directly we cannot convert this one into 0.37. No, where we have to convert that same way only, but where we have to apply, that is very important. Now, what is the option? I mean, what is the correct answer? It is 4.44 gram. Now, which the option, it is 4.44 gram, 4.44 milligram, 4.44 into 10 to the power of minus 3 milligram, 0.444 mu gram, right? Microgram, like. See, in that, which is the correct option? See, when we see the option, we are getting actually confused, right? Now, let us explain again. Here, we have seen what it is. ml only, no, 10 ml into 1.2 gram per ml. ml will be cancelled. So, gram only it is there. So, gram if it comes means, how come it will come as a milligram? See, now they are giving really twist over here. So, you should be confident your answer. See, in that milligram, it is not possible. Here, this milligram, it is not possible. Even 4.44 into 10 to the power of minus 3 milligram. Of course, it is very small when we compare to that gram. Mu gram, it is not at all possible, right? So, we are not supposed to confuse when we see the options, because we have thought out and we have got that answer. We are applying in the concept and we are getting answer. But still, you have to be very confident in your answer. You should have confidence in you. That is only the what it is, solving the problem, that will give that assurance, and you will get the confident number of questions. If you solve, really you will be a powerful person to solve all the life problems. Yes, so which is the correct option? Option A is the correct option. Come on, let us go to the next question, right? Calculate the molality of 1 liter solution of 80% H2SO4 W by volume, that is weight by volume, given that the density of the solution is 1.80 gram per ml. Right, now here they are asking about the molality, right? Now for the density they have given. Okay, let us write the data according to that question, right? Density equal to what it is? Mass by volume, right? Now mass of the solution, can we bring it here? So mass of the solution means density into volume, this one, right? Now the next point here, density, how much they have provided here 1.80 gram per ml, right? Gram per milliliter inverse. So I just mentioned 1.80 gram per ml, right? Now volume, how much they have given here? 1 liter they have given. 1 liter we just converted into ml, so 1000 ml. So this ml and ml will be cancelled. So how much it is actually? 1800 gram. So mass of the solution, it is 1800 gram. So mass of the solution, in the sense here what we are bringing that point, mass of the solution H2SO4 only, H2SO4 only, right? Here H2SO4 only they have mentioned. No, so mass of the solution H2SO4 only. Right, now next one, mass of the here molality they are asking. No, so we have to find out that mass of the solvent and mass of the solute, right? Mass of the solute, let us identify, because they have given the percentage wise. Right, now here percentage, 80% they mention. No, so mass of the H2SO4 solute I just mentioned. So solute I just mentioned. So here how much? Here mass of the solute, how do we identify? Here volume into percentage. So volume how much? 1 liter they mention. No, so 1 liter we just mentioned it is 1000 ml. And percentage how much they mention? Here 80%, right? 80%, right? So we can bring it in that way, 1000 into 80 by 100. So what is the answer you will be getting? So this and this will be cancelled. So you will get how much? 800 grams. So this is gram only, right? So you'll be getting mass of the solute. See, mass 800 gram. Now this is actually solute. Now we have to identify the mass of the solvent. I hope you got the clarity. We have to find out mass of the solvent. Mass of the solvent how much? Here 1800 gram already we just mentioned mass of the solution. This is solution only. Now solvent we have to identify. Solution means what it is? Solvent and solute combined together it is called a solution. So solute how much we got it? 800 grams, and solution it is 1800 gram. So we can so from the solution we can minus that solute, so we will get that what it is? Solvent. So 800 gram, that is what I just mentioned, solute. So you will get how much? So you will get 1000 gram. That is also equivalent to 1 kg. Can we write it in that way? That will be more easier for us. Right now here, now moles of the H2SO4 easily we can identify, because given mass and molecular mass, through that we can identify. So moles of H2SO4. So moles of H2SO4, it is given mass by molar mass. So given mass, which one we have to take it? Given mass we have to take it always mass of solute only. Please note down, given mass we have to take it for mass of solute. So how much we have taken? It is 800 gram. So 800 gram divided by mass of H2SO4, that is universal dialog, that what it is? 98 gram per mole. You know very well, right? It is a king of the acid, so we know very well that is. So this is 98 gram per mole. So now what is the answer you will be giving? Here you will get 8.157 moles, right? I hope you got the clarity. Moles of H2SO4, you got it. Now, molality, we have to identify. That is only the question, right? Molality. So, molality equal to moles by mass of solvent. Now, we have to identify mass of solvent. Solute, it is a given mass. Mass of solvent, where we have to use, finally, we are calculating the molality. No, there we have to calculate it. Please note down. So, this is mass of the solvent in kg. Right. Okay. So now here moles, it is 8.157 moles divided by mass of that what it is? Solvent. Here how much we found? Here 1000 grams, right? 1000 grams it is in kg, right? So here I just mentioned here 1000 grams or 1 kg. So what is the answer you will bringing here? So you will get around 8.156. I mean 157. No, so we can bring it 16. So this is molarity. No, molality, how can we bring it? Mole per kg. I hope you got the clarity. So molality of H2SO4 of the given data, given molality of H2SO4 of the given solution, right? So which is the correct option? 8.16, right? Come on, let us check the answer. These are all very easy only, but you should know how to tackle this problem, right? Right now, which is the correct option? Option A. Yes, exactly. Option A is the correct option. I hope you got the clarity. These are all very simple questions. Come on, let us go to the next question. The next question. fluoxymesterone. It is a steroid. C20H29FO3 is an anabolic steroid. A 500 ml solution is prepared by dissolving 10 milligram of the steroid in water. In that, 1 ml portion of this solution is diluted to the final volume 1 liter. What is the resulting molarity? See here, this what it is, steroid, it is there, no? The steroid, actually, how much it has taken? 10 milligram it has taken. So 10 milligram it has taken, and what it is, 500 ml. So in that this is actually 500 ml, right? Now that is prepared 500 ml. Now in that, here how much we have taken? Here 1 ml they have taken, and that is diluted with that, what it is? Diluted with that 1 liter. So that means this is 1 liter. So in that 1 ml it has taken, in that 1 liter which is diluted. So that means how much it will be diluted? This is 1 liter. This is half a liter, and this is 1 liter. That to what it is, from that 500 ml, only 1 ml has taken, and that is diluted by what it is in 1 liter. So what is the resulting molality? That is the concentration. So the concentration will be very least, I think so. Come on, let us check here. Mass of the steroid. Okay, now here, one by one, let me write it for you to understand. So that fluoxymesterone, it is actually a steroid tablet actually. Okay, so mass of the what it is, steroid. So mass of the steroid, it is 10 milligram, right? Now here, so 10 milligram, here we just converted into gram, because grams and kilograms, it will be easy instead of going for milligram. So 0.010 gram. I hope you got it. So mass of that steroid, it is 0.010 gram. Now initial volume of the solution, initial volume of the solution. Initial volume of the solution only, no, 10 milligram we just added, and we make it as a, so initial volume, it is 500 ml, right? Okay, now next one, what it is? Sample of volume which has taken from that, how much ml? It is 1 ml. So I just mentioned here, from the sample volume, that is portion, in that they mention, no, and that one portion, no, so volume portion has taken how much it is? 1 ml. So 1.0 ml. So 1.0 ml we just converted into liter, 0.001 liter. I hope you got the clarity. Right, now final volume. So final volume, this is the final volume. From that final volume, initial volume and final volume. Initial volume, it is 500. Final volume. I hope you got that idea. Why I'm giving all these ideas? Because it is like a comparing a dilution. No, that formula we have to use it. M1V1 equal to M2V2. That formula only. Yes, that is what I wanted to bring this point. So here we just take it, actually this one we can take it as yeah. So here how much we have taken? It is 1 liter. So this one we take it as final volume, we can take it as V2. Initial volume we can take it as V1. Okay, so this is V1, this is V1, and this is V2. Right, this is V1 and this is V2. So V1 it is a half liter, that V2 it is 1 liter. Okay, in that way. So V2, how do we bring it from that to 500 ml? In that 1 ml we have converted into that one, I mean diluted into that 1 liter. So molar mass, now coming to that point. Dilution got over. Now we can make it all those details here. So molar mass of steroid. Molar mass of steroid. So molar mass of steroid, how much? What it is? C20 H29 FO, right? Yeah, FO3. So if you calculate all together, so very big number you'll be getting, right? So 336.44 gram per mole. Right, this is molar mass, right? So this you will get like that only. Right, now here moles of initial solution, right? Here moles of initial solution. Moles of initial solution, mass, here what it is? Mass by molar mass. So first initial solution let us take. So mass by molar mass. So given mass, it is what it is, 10 gram, right? So we converted into what it is, 10 milligram, we just converted into gram, 0.010 gram by molar mass, 336.44 gram per mole. I hope you got that idea. Now here answer, initial solution, that is 500 ml. No, so for that, what is the mole? Here 2.972 into 10 to the power of minus 5 mole. I hope you got the clarity. So this moles, it is actually we got it from 500 ml, right? Now we have to find that molarity, initial molarity. Initial molarity. Molarity. So initial molarity, it is 500 only, right? So this is M1. I hope you got the clarity. Now V1, V2 we found. Now M1, it is initial molarity. So that is moles by volume in liter. So here what it is? 2.972 into 10 to the power of minus 5 divided by 500 ml, right? So we converted into liter, 0.5 liter. So initial molarity, what it is, M1, we can get it as 5.944 into 10 to the power of minus 5 molarity. Molarity is also known as what it is? What it is? Mole per liter, right? I hope you got the clarity. This is M1. Now we have to identify M2. M2, it is what it is. We should go for that sample. We mixed it to that 1 liter. No, so that is so moles of the sample. That portion we have taken now 1 ml. So sample portion have taken. I just write clearly so that for you to understand. Taken, right? Okay, now molarity. See, molarity into volume in liter. So here, so already we got this molarity M1. This is M1, right? M1, capital M1, molarity, right? So this is molarity into molarity 1. So here, what is that molarity? We got it 5.944 into 10 to the power of minus 5. Okay, this is molarity M1 into volume in liter. That is 0.1, what it is? 0.001 liter. Now 1 ml we have taken. No, we just converted into liter. That is 0.001 liter. I hope you got the clarity why we are applying this. So you will get how much? 5.944 into 10 to the power of minus 8 mole. Right. So you will get what it is, number of moles. You got this one, right? So what is that? Moles of the sample have taken. So that molarity into volume of that solution. Molarity, what we got it from half liter. From that only we have taken 1 ml. So that point only we just applied. That is molarity into volume of solution in liter. So this is answer you are getting. Now we have to identify the molarity of final volume. Right. Molarity, final molarity, right? Final molarity. Final molarity of that sample. Now this is M2, right? So come on now, moles by volume in liter. So moles by volume in liter, 5.944 into 10 to the power of minus 8 divided by 1 liter. No, that we have taken it as 1 liter. No, so now what is the answer you will be getting? So you'll be getting around the resulting molarity, it is same as it is. So 5.944 into 10 to the power of minus 8 molarity or mole per liter or mole per liter. That is what this is, mole per liter volume. Right now, final volume of that, what they are asking, that is the question, right? So 5.944 into 10 to the power of 8 molarity. So I hope you got the clarity. How do we identify? That's what purposely I just explained with the diagram so that it will be easy for us to identify. First one, it is half ml. Second one, from that half ml, from that half liter, into one small portion, that is 1 ml we have taken and diluted into 1 liter. See, which is the correct option. I think you will be answering for this point. 5.944. So 5.944 we can convert it into 5, right? So 5.944 into 10 to the power of 8 molarity. So option C is the correct option. So option C is the correct option. So this is molarity, capital M, molarity. See, molarity means small m, molarity it is capital M. I hope you got the clarity. And even you can mention in moles per liter, because molarity it is related about volume of the solution, whereas molality it is related about solvent in kg. I hope you got that idea. Come on, let's go to the next question. The next question, the 25 ml of 0.15 m solution of lead nitrate PbNO3 twice reacts with all of the aluminum sulfate Al2SO4 thrice present in 20 ml of a solution. What is the molar concentration of Al2SO4 thrice? Now they have given the equation also. 3 PbNO3 twice aqueous plus Al2SO4 thrice aqueous solution. You will get 3 PbSO4, that is solid PPT, plus AlNO3 thrice, that is aluminum nitrate. Right now here we have to identify what it is. What is the molar concentration of Al2SO4 thrice aluminum sulfate? We have to identify. Yes. Okay. Now let me write that equation for you to understand more clearly. So 3 moles of PbNO3 twice plus Al2SO4 thrice gives 3 moles of PbSO4 lead sulfate plus AlNO3 thrice. So aluminum nitrate. So here we have to check the moles. So 3 moles of lead nitrate require 1 mole of aluminum sulfate. So that moles ratio, it is 3:1. You please remember. Right now here, now let us check the data's volume of the solution. Volume how much we have taken? Here 25 ml. 25 ml. So here 25 ml of 0.1 m solution of lead nitrate. So this we can make it lead nitrate PbNO3 twice, right? So volume of lead nitrate, we just converted into liter, that is 0.025 liter, right? So this ml we just converted into liter, and the same way molarity also they mention. I just mentioned here only because volume of PbNO3 twice, because here no, we just get confused with the liter and all these things. So let it be here. So this is, we just converted into liter. The volume of PbNO3, this one. And the same way molarity of PbNO3 twice. PbNO3 twice. How much it is actually? 0.15 m. See, this is actually molarity, or we can mention it is mole per liter. Right, got it. Now, moles of PbNO3 we have to identify. So, moles of PbNO3 twice, that is equal to molarity into volume in liter. Right, molarity how much? Here just now we found that is 0.15 m. Volume in liter 0. What it is? Just now we find right now. Here it is 0.025, right? 0.025 liter. Now, what is the correct answer you will be getting? So, you will be getting around 0.00375 moles, right? So, moles of PbNO3 we found. Now, here actually in the balanced equation already I mentioned, 3:1. So, 3 moles of lead nitrate require 1 mole of aluminum sulfate. So that means moles of Al2SO4 thrice we have to identify. So that is, we just mentioned here 3:1. So that is moles of what it is, Al2SO4 thrice we have to identify. So moles of PbNO3 twice divided by 3. Right, 3:1. No, that is what I just bring it. So moles of PbNO3 divided by 3. So moles, how much we got it? Here we got 0.00375 mole. Right, divided by 3. So what is the answer you will be getting? Moles of Al2SO4 thrice. How much you will be getting? 0.00125. You'll be getting, that is moles. Right. So moles of Al2SO4 thrice also you got it. Now in the present solution they mentioned, right. Here in the present 20 ml of solution it has mentioned, no? So present solution what it is? 20 ml. Okay. So present solution, it is 20 ml. Right. So here also we just converted into liter, 0.020 liter. Right. Now here molarity we have to identify. Molarity. So molarity equal to moles per volume, right? Moles per volume in liter. So always you remember. So here 0, what is that a mole? We got it this only, right? Here moles of Al2SO4 thrice. That is what we have to identify. Present solution Al2SO4 thrice. Everything specific I'm mentioning because you have to understand very clearly. That is what I wanted to tell. Right now here we just mentioned that moles. Know how much it is? 0.00125 mole divided by volume in liter, 0.020 liter. Right now, what is the answer you will be getting? You will be getting around molarity. Here, 0.0625 molarity or moles per volume. Right. Now, the molar concentration of of Al2SO4 thrice. That is what the question they are asking. So here 0.0625 m, or else mole per liter or unit mole per liter. Because why I'm giving this idea? Because in the option both will be there, but you should not get confused. You should have that confidence in yourself. So you can solve all the problems. See, whatever problems you're facing in your life, you should have confidence in you. Yes, I am able. I can solve. So in that way, you have to be bold enough to yourself. You are not supposed to panic for anything and everything. You have to be bold enough with God's help. Right now, come to this point. By the way, here, what is that answer we got it? Here we got 0.0625 m. I just mentioned no. So we can convert this also here. See, just now I mentioned, don't get panicked. So here again they mentioned 10 to the power of -2. So this is nothing, 10 to the power of just this point. We bring it here. 6.25 into 10 to the power of -2. Capital M, molarity. Right. So this is capital M, mole per liter. That is represents molar concentration. Molarity. What is this molarity? Molarity. I hope you got the clarity now. Which is the correct option? Option A is the correct option. Yes, you got it. Come on, let us go to the next question. I hope you got the clarity. How do we identify all these points? Right? Come on. Yes. So this is the answer. We got it. The next question. Concentrated HNO3 is 63% of HNO3 by mass and has density 1.4 gram per ml. How many milliliters of this solution are required to prepare 250 ml of 1.20 m, that is molarity of HNO3 solution? See, they have given very clearly concentrated HNO3 is 63% of nitric acid by mass and has the density they have given. So density, it is actually what it is, mass by volume. And how many milliliters of this solution are required to prepare 250 ml. So that means it is like a comparison, like M1, M2, yeah, V1, V2. In that way, we have to consider. And the same way, I wanted to mention one more question here. 93, question number 93. This also a little bit similar. Here, calculate the molality of 1 liter of solution of 80% H2SO4 weight by volume given and the density of the solution. So here they have given the solution, but in this question, that 96 question number 96, they have given that what it is mass, but here they have given that volume, that is liter. So how do we calculate it? So here the same mass of the solution, density into volume of the solution, they same as it is. But here the second point here, mass of the solute, that is mass of H2SO4, what they have given, volume into percentage. So volume, actually that is what I wanted to mention. Volume they have given. So we are calculating volume into percentage. See, the same percentage they have given in that question also. So let us compare these both. In this question, they themselves have given volume. But question number 96, they did not give volume. They have given that mass and has the density. So they have given indirectly, that is mass by volume, density only they have given. Right now, how to calculate it, how to solve this sum. Okay, as according to this question, let us write the data so that it will be easy for us to identify the answer. So first and foremost, molar mass of the solution, that is molar mass of HNO3. Right, molar mass of HNO3. So this is molar mass of H2SO4, HNO3, HCl and all. It's a mandatory that you should have known very well. That is 63 gram per mole. Right. So molar mass of HNO3, because acids, all concentrated acids and all, often we are using no, so that will be thorough for it. Okay. Now mass of the solution. Right now, first and foremost, we'll write that mass here in this point, mass of the solution. Mass of the solution means what it is, HNO3 only. Right. So solution means a solvent plus solute. So that is combined together only. It is called what it is, solution. Right now here, mass of the solution, here what it is, how much they have given, it is actually density way they have given. So density way they have given means it is volume in liter into density. Right, density. So density equal to what it is, density equal to mass by volume. Right now here volume in liter they mentioned, you know, so volume in liter, here generally volume in liter, it is 1 liter only, right? So we can mention it is 1000 ml. Into density they have given, it is 1.4 gram per ml. So this ml and this ml will be cancelled. Now which is remaining, gram. So mass of the solution is the answer. It is what it is, 1400 gram. So I hope you got that idea. So mass of the solution HNO3 combined together, it is 1400 gram. Here specifically they did not give any volume of the solution. Right now only mass of the solution we got it. That to what it is, through density we have got it. Now the second step, what it is, mass of the HNO3. Okay, so mass of the HNO3, how do we identify? Because here they have given percentage. Percentage they have given, no. So percentage they have given means here mass of HNO3. It might be solute, right? Okay, so here total mass into percentage. The same question, same type of question. Here question number 33. Here the second step, what I mentioned, mass of the solution, that means mass of that H2SO4 solute, volume into percentage. But the same point, I just to bring it to this point over here, the same point here, total mass of total mass. So this is the total mass actually, total mass into percentage. So you see the difference for both the questions. Both the questions are same concept. Only thing here, that question it is volume mentioned, they have already given in that question, but here we are finding that and we are calculating total mass. This is a total mass. They did not provide anything through that 1000 ml and a density. So that is 1000 ml. It is a mandatory that we can take it there. Okay. So a percentage. So percentage, how much they mentioned? It is 63. Total mass, it is 1400. How do we get 1400? You know very well. Right now here, how to calculate it? 1400 gram into percentage 63 by 100. Right now, this and this will be cancelled. Now, what is the answer you will be getting? You will be getting around what it is, 882 gram. So mass of this solute, HNO3, you got it. Right now, that is actually a given mass. Now, we can identify that molarity. So we can make it, it's a given mass. Given mass it is. Now, we can find out the molarity. So molarity, it is nothing what it is, moles per volume in liter. So here actually given mass we have to identify. What is the given mass? This is the given mass. So this is actually given mass. That is what from the whole we are finding that through percentage we are getting that given mass. So given mass equal to, I just mentioned, given mass of HNO3. Suppose if they mentioned molality, we would have taken it as a solute. But here molarity, we can take it as a given mass, right? So you please note down all this where we have to identify all those points. Right now here, 882 gram, that is what it is, given mass. And molar mass of HNO3, 63 gram per mole, you know very well. And here volume in liter. So what is it, volume in liter? 1 liter. It is 1 liter, right? Here, that is 1 liter commonly. Right now, let us apply the values. So molarity equal to molarity. This is M1 we can take. Why? Because they are comparison. Both the points it has mentioned. No? That is M1 equal to what it is? Moles per volume in liter. Right. So moles per volume in liter. So moles per volume in liter. Moles, it is actually what it is? Given mass by molecular mass. So given mass by molecular mass into volume in liter. Right. Can we apply all these values? So here 882 divided by 63 gram per mole into volume in liter, what it is? 1 liter. Right. Now, what is the molarity? So finally, we are coming to that molarity of M1 because 2 molarities they mentioned. So this is the first molarity. So this is actually 14 M. Right, M it is mole per liter also we can identify. So 14 molarity, this is M1. I hope you got the clarity. Now let us find the second molarity. So second molarity, the same idea we can identify. How to identify? The same thing. Here, I just to bring it to the question for you to understand. So the second question, second point, what it is, how many milliliters of this solution are required to prepare 250 ml of 1.2 m HNO3? Come on, let us identify this point from this value, right? Number of moles, again, number of moles of 250 ml equal to, so actually number of what it is, 250 ml we just converted into liter. So that is 0.250 only, right? So we can convert into liter. This is, we can keep it as a V2, right? Now the same way molarity. So N2 it is a moles, number of moles. So the first one N1, no? So this is N2. Right now here molarity of the solution. Here molarity of the solution. Molarity already they have given. Molarity of the solution. This is M2, we can keep it. So M2, that is M1 and this is M2. So how much it is? Actually 1.2 M, right? 1.20 M. Right now here N2 equal to, generally what it is, molarity into volume in liter. Molarity into volume in liter. So this is volume in liter. V2, it is volume in liter. Now we have to identify the dilution formula. You know what is a dilution formula? Dilution formula, you know very well what it is. M1V1 equal to M2V2. So M1 and M2 already we found. V2, just now I showed you, know, this is V2. Okay, what they have given. Now we have to find out that V1. Okay, now for that we just what it is, bring all the values so that it will be easy for us to identify the answer. M1, we just bring that answer. M1 we have found, no, this is 14 M. So I just bring all the points so that you will remember. So this is 14 M now. 14 m molarity. And M2 just now we found, no, this is already they have given in the question only 1.20 m. Right now V2 it is 250 what it is 250 liter it has mentioned. Actually in the question they have given what is it, how many milliliters only they are asking. So let it be milliliter only, no need to change into liter, because here for the mole sake we have converted into liter. For molarity into volume in liter, for moles we have just converted. But now here we can identify here what is the answer. Moles, you got it here. Molarity, number of moles. Here I just wanted to mention here one point. Number of moles equal to here volume. Molarity it is 1.2 m into 0.250. So you'll be getting around how much? 0.30 moles, because this moles are very important. This is, we can take it as N2. As I mentioned, this is N2. I just forgot to tell at this point. So as I go for dilution formulas, that I interested to go that side. Okay, right, fine. Come on. As we go for it, we can keep it as a ml only. So that means 250 ml. I hope you got the clarity. See, here we converted for liter. That is the way I found here. Found my mistake, right? Sorry for it. Okay, now here 0.25 liter we converted. No, because of molarity into volume in liter, to find out the number of moles, for that is the reason we just converted into liter. But here in the question milliliter only they are asking to find that volume in liter. So let it be 250 ml. How much ml milliliter required to convert this, such kind of question, right? So let it be here. And now V1 M1 V2. So V1 only we have to identify. So that means M1 V1 equal to M1 V1 equal to M2 V2. So here V1 we bring it outside. So M2 V2 divided by M1. So let us apply the value here. So here what it is? M2 it is 2.0 into here 250 ml. 250 ml. Please note down. Here M1 what it is? M1 14 m. This is M1 and this is M2. Right now here this M1 M will be cancelled. Right now here what it is, ml only waiting, because we have to identify V1 volume, right? So naturally ml will be there. So when you calculate this first one top, you will get 300 divided by 14. So altogether you will be getting 21.42 ml. Right now we got the point. Volume V1 equal to 22.42 ml. Right now see here what is the question they are asking. To prepare 250 ml of 1.20 molarity HNO3 solution. Here how much required? Volume how much required? 21.42 ml of 63%. They mentioned in the percentage, no? Concentrated HNO3, that is concentrated HNO3 nitric acid solute is required. Right, so this is actually M1 V1 M2 V2. So I hope you got that idea. See what are the steps we are following, and how I just compared with that question number 93, and this is 96. In that question number 93, volume they have given, but here mass they have given. How to deal this question, I think you got a better idea. If you want, you just check it once again, that question number 93 and question number 96, you see the difference and you find the answer. So like this number of times, if you go through thoroughly, or you just practice it twice or thrice, so definitely you are able to identify what are the points to be noted down, right? I hope you got the clear idea. Come on, let's go to the next question. Now by the way, which is the correct option? Option B is the correct option. So how much? This is liter, ml, this is ml, this is ml, milliliter. So option B is the correct option, 21.42. Yes, come on, let's go to the next question. The next question, 50 ml of 20.8% weight by volume BaCl2 barium chloride aqueous, and 100 ml of 9.8% weight by volume, that is H2SO4 solution or mixed. Molarity of Cl minus ion in the solution is atomic mass of barium 137 gram per mole. Yes, now how to calculate this? Like question number 92 we have gone through, no, the same, but here comparison BaCl2 and H2SO4. Right now let us check this one also. Right now here atomic mass, I mentioned atomic mass of barium Ba, it is actually 137 gram per mole. Generally they will give all that molar mass, atomic mass and all they'll give, but Anyway, you have to remember some things. Right now, let us identify each and everything here. 50 ml of 20.8% weight by volume of BaCl2. So mass of BaCl2. Mass of BaCl2. What is it, BaCl2? By the way, barium chloride. Yes, here 50 ml of 20.8%, that is weight by volume. So how to convert it here? Actually, 20.8 divided by 100 into volume. That is what? Volume into percentage. Volume into percentage or mass into percentage. That is the way we can identify. Right now, so you will get volume how much? 50 ml. Right. 50 ml. I just mentioned here volume here, volume into percentage, so that you will remember that. So usually when we have that key, easy to understand. So that's what I'm just bringing all these points. So what is the answer when you calculate this? So you will get around 10.4 gram. Right, you will get gram because this here ml will be cancelled, 100 ml in that percentage, right? So here 10.4 gram, and by the way, it is mass only we are considering, always gram. So 10.4 gram, that is mass of BaCl2. Now we have to identify moles of Cl minus. Question number 92 also, chloride ion. We mentioned, question number 92, you please check it. So moles of Cl, chloride ion. How to identify? So here what it is, BaCl2, if we separate Ba2 plus 2Cl minus ion. Okay, so 2Cl minus ion. So molar mass of BaCl2, molar mass of BaCl2, how much? Ba, it is 137 gram per mole, and chlorine 35.5. So altogether 2 times 35.5. So when you calculate together, it is 208 gram per mole. You just calculate it so that it will be easy. Otherwise, it will take longer time to complete this video because it is 10 questions at a stretch. Some questions are bigger. That is like important questions also. So that is what. Right now, here moles of Cl2. So here moles of Cl2, what it is? Here 2 moles are there. Right, 2 moles. Right now, completely moles of Cl minus ion, that is 2. Right now, moles of BaCl2, moles of BaCl2 completely. So that is given mass by molar mass. Given mass by molar mass. Given mass, what it is? We have to got from here. Where do we get from here? This is mass of BaCl2. It is a given mass. Okay, it's a given mass. Please note down all these. But all what to say, you no need to get confusion. That is the reason often I'm just bringing the points. So given mass by molar mass. Given mass, it is 10.4 gram, and molar mass, it is 208 gram per mole. Right now here gram cancel. So how much you will be getting? 0.05 mole. So moles of BaCl2, 0.05 mole. Right now we got it. Now total moles you have to identify. What is the total moles? Total moles. Mass moles. Total moles means what it is? This mole, BaCl2 mole and Cl minus ion. 2Cl minus ion. So that is 0.05 into 2. That we got it from Cl minus. How many Cl minus? It is 2. No, that is what? So you will get how much? That is 0.1 mole. Right? So total moles of BaCl2. BaCl2. So total moles of BaCl2, it is 0.1 mole. See how going around the neck, the questions and answers. But you have to be thorough, and it will be easy to understand if we explain completely. Now total volume we have to identify. Total volume. So total volume, what it is? First it is 50 ml of BaCl2. Yeah, just I'm bringing the question. Here 50 ml of BaCl2, and what it is here next 100 ml of 9.8% weight by volume of H2SO. For total volume, right now we have to identify that. So total volume, so 50 ml of BaCl2 plus 100 ml of what it is? H2SO4. So altogether you will get how much? 150 ml. It is a total volume. We are not specifically we are not bringing. We just bring total volume. Right now we have to convert into what it is? Liter. So this is 0.15 liter. So where we have to convert into liter, where we have to convert, keep it as it is like ml. Please note down, because last question also ml, we just bring it that idea. Right now here I just bring the equation BaCl2 because it is total now. So it will start reacting. So H2SO4. So what you will get it? BaSO4 plus HCl. So this is 2 and this is 2. So you will get 2 HCl. Right now this is displacement reaction. This is another one more point to remember. So This is what it is. BaCl2, it is so BaCl2 and H2SO4, it is like BaSO4 and HCl, it is a displacement reaction. Now, next one, final molarity we have to identify. Final molarity. So, final molarity, how to identify? Total moles. Cl minus ion, that is especially, right. Total moles divided by total volume in liter. Please note down. So total moles, you know very well. What is the total moles? Here we just bring it now. Total moles. This is total moles. Total volume, how much this is? That's all. We just apply the value. That's what. Always remember. It will be easy if you note down the data, informations. That is a knowledge. That is power. Knowledge is power, right? So datas are power here. 0.1 mole, right, divided by 0.15 liter. So what is the answer? You'll be getting 0.6667 molarity. Right. Now resulting solution. The resulting solution. You will get how much? 0.6667 mole per liter or molarity. Anything we can keep it. Right. I hope you got the clarity. Resulting of the solution. Come on, let us check the option. So what is the option? 666. That is 66667 I just mentioned. So the answer, it is 666. So I hope you got the clarity. This is molarity of the resulting solution. So mole per liter also we can keep, or molarity. Right? Come on, let us go to the next question. I hope you understand this question. The next question. 100 ml of 10% NaOH weight per volume is added to 100 ml of 10% HCl weight per volume. The nature of the resultant solution. See, this is really interesting. Previous video we have gone through such kind of question, but something different. Values are different and even the points are different. Come on, let us check how to deal this question. Now, as we mentioned here, weight per volume, that is mass of the solute, and the same way mass of the solvent. Right, let us go and identify very clearly. So mass of the solute, mass of the solute NaOH, how much here? 100 ml, both are 100 ml of 10%, both are 10%. So mass of the solute, how do we identify? As I mentioned, mass, if they are giving grams, or mass means mass into percentage, or if they are giving volume means volume into percentage. So volume into percentage, 100 ml into 10 by 100. Got it? So how much you'll be getting? It is 10 grams only, because ml will be cancelled. It is 10 grams. So in 100 ml, 10 grams it has mixed. So that is 10%. Okay, so 10 gram. Just mention this. Okay, so it is 10 gram. This is mass only. No, so mass of that NaOH, mass of the solute NaOH, 10 gram. Right. Now mass of HCl, the same mass of HCl. This you don't ask. This is solvent or what? So mass of HCl. This also 100 ml of 10%. Right. Now here the same idea we can bring it. So 100 ml of 10%, the same here also you will get 10 gram only. So mass of HCl also same, it is 10 gram. Right. Now number of moles we can identify. Number of moles of NaOH. Right. So here given mass by molar mass. So given mass by molar mass, NaOH how much? Here 10 by, here NaOH what it is? 40 gram per mole. This also you know very well. This is also famous because strong base, always we will use NaOH only, strong base. You know one thing, we are using soap, no? That is also, we are using toilet soap, no? That is also, we are using sodium hydroxide with edible oil only, right? Okay, now come to this point. So here 40 gram per mole, and here gram, 10 grams. So what is the answer you will be getting? 10 by 40. So you will get around 0.25 mole. 0.25 mole. So sodium hydroxide mole, it is 0.25 mole. Please note down, because we have to compare both the moles. Right. Now the same way, moles of HCl. Number of moles of HCl. Okay. So number of moles of HCl. So the given mass by molecular mass. So here also 10 by HCl, it is 36.5 gram per mole now. Right. Now here, see here 36.5 gram per mole. Here gram. This gram and gram will be cancelled. So you will get the answer around 0.274 mole. So moles of HCl, it is 0.74. Okay. Now compare both the thing. Right now, we should compare. So NaOH plus HCl. You will get NaCl plus H2O. Salt and water. Strong base and acid, you will get salt and water. Right now, this is also 1 and this is also 1. So 1:1 first. 1:1 ratio. So 1:1 ratio, we have to identify what it is, moles. So moles of NaOH, moles of HCl. So HCl just now we found no. So what is it here? What it is 0.274 and moles, and here 0.25 moles. Please check it once again if you want. Right. So this is moles of NaOH. This is moles of HCl. Right, both the thing. Now, which is excess point? It is very, 0.02. It's very. So, which is excess? Which is limiting? Of course, this is 1:1 only. But which is limiting? Which is, of course, 100%. This is limiting. This is limiting, and this is excess. Where see 0.02, it's very. Even your JE marks, whereas you are going for that percentile, no, that 0.001, that is also they will check. So okay, come to this point here. We are solving this problem right now. When we solve this problem, that problem will not appear at all because your marks will be more higher and higher. Right now, which is excess reagent, which is a limiting reagent? Sodium hydroxide, it is a limiting reagent. Limiting reagent. And HCl, it is a HCl, it is a excess reagent. Excess reagent. So the excess reagent only decides what it is, nature of the solution. So excess reagent decides the nature of the solution. Nature of the solution. Nature of the solution. Now I think you got an idea which is what is the nature of the solution. The solution, it is actually what it is, acidic in nature. Why? Because HCl, it is having 0.02 excess. So this is acidic in nature. Acidic in nature. I hope you got the clarity, right? Now what is the answer here? Yeah, alkaline, strongly alkaline, acidic. This is 100% acidic in nature, right? I hope you got the clarity. This is the way you can identify very easily, because this is number of moles, how to identify. Even question number, previous video also I just mentioned this type of question. Please check it once again if you want. Okay, now come on, let us go to the next question. This question I just mentioned here only. Come on, let's go on. Now the next question, how many milliliters of 0.1 m H2SO4 must be added to 50 ml of 0.1 m NaOH to give the solution that has concentration of 0.05 m in H2SO4. Right now in the question here, molarity they have given, H2SO4 molarity they have given, and that must be added to 50 ml of 0.1 m NaOH. So NaOH molarity also they have given. Right now they have given that volume also they have given for sodium hydroxide, but we have to identify that volume of H2SO4. That means V1, V2, V1 we have to find out, V2 they have given. Right now finally that solution of the concentration, it is 0.05 m in that H2SO4. So how much ml if we add, we will get this type, this point of molarity we will get. So that is the way the question has given. Right now, come on, let us write that equation, then we will write all the data, then finally we will see the result. Right now here, what are the points to be noted down here? H2SO4 plus NaOH, it gives Na2SO4 plus H2O. So here in this NaOH, Na2SO4, no, so here 2 NaOH. Right now here H2 and here also OH2. So automatically you will get what it is, 2H2O. So is it balanced? Yes, it's balanced right now. Now next to one, we have to find the formula to solve. What formula can we use? We can use this formula. You know what it is? It is N1V1 minus N2V2 equal to NR, resulting solution, NR into V1 plus V2. I hope you got that clarity. So what is the formula can we use? N1 V1. N, it is what? Normality. Normality, how to identify? Molarity into N factor. Yes, right. I hope you got that idea. So N1 V1 minus N2 V2 equal to N. Here also normality only N. Resulting solution. This is the resulting solution. 0.05. It is a resulting solution into V1 plus V2. Yes, got it. Okay, now I would like to give all the data. According to that, you will identify. So before giving the data, I will mention this point here. Normality. Normality equal to molarity into n factor. N factor. So molarity into n factor. Molarity they have given here. Molarity they have given. N factor, number of electrons losing and number of electrons gaining. In that way, we can identify valency factor and n factor. Right now here in this point, N1, V1, we can keep it as what it is, H2SO4. And the same way, N2, V2, we can keep it as NaOH. I hope now you got an idea. So N1, it is molarity into N factor. Molarity of H2SO4, it is what it is here. So here I just mentioned so that N1 V1 minus N2 V2 equal to NR, resulting V1 minus V2. Right now, I will write the data. N1 here, how much? 0.1. 0.1 into N factor, how much here? For this N factor, it is 2. Into V1, V1 only we have to find out. They are asking no, how many milliliters. So we have to find it. So this one we can keep it as V1. Right now, minus N2. N2, the same normality. Normality is what it is? Molarity into N factor. So molarity of this one, 0.1. This is what it is? 0.1. 0.1 into N factor. Here it is 1 only. N factor it is 1 into and V2 it is 50 ml. Right. I hope you got the clarity. Now here equal to resulting solution of NR. Resulting solution. Now N means what it is? Molarity. So molarity how much it is? Here 0.5. Right. Here 0.5. 0.05 into what it is? Here valency factor. Valency factor it is 2 into V1. V1 we have to find out. And V2 it is 50 ml. I hope you got all the datas over here only. That is what purposely I just mentioned here in this color. We have to identify that. So now can we calculate this? So 0.1 into 2 into V1 minus 0.1 into 1 into 50. Again, I'm writing the same, right? Okay, 0.05 into 2 into V1 plus 50 ml. Right. Okay. Now, when we calculate this, so we will get 0.2 V1 minus, here how much you will get? 0.1 into 1 into 50. You will get 5 only. That is equal to 0.05 into 2 into V1 plus 50 ml. So, how much you will be getting? Here, 0.05 into 2, you will get what it is? 0.1 into V1 plus 50 ml. Right? Got it? Okay. Now, we can bring all this one here. 0.2 V1 minus 5. Okay. So, already it has mentioned now all that V1, 0.2 V1 minus 5 equal to 0.1. We just multiply this. 0.1 V1 plus, what it is? 0.1 into 50. How much? 5 only. Right. So, now all that V1 we bring this side. So, here what it is? 0.2 V1 minus 0.1 V1 equal to 5 plus 5. So, here 0.1 V1 equal to 10. So, that means V1 equal to 100. So, here ml only we are considering V1 equal to 100 ml. So, V1 equal to 100 ml. See, this question actually looks easy, but as we are dealing that, this formula, I think this will be able to identify the answer correctly. Yes. So, which is the correct option? Option C is the correct option, 100 ml. Right now, again, I would like to mention this. Normality, it is nothing. Molarity into N factor. How to deal that molarity? Already they have given that molarity. In that one volume they have provided, the other volume we have to identify. So, in such a way, we bring this formula N1 V1 minus N2 V2 equal to NR. This is a resulting solution of molarity into V1 plus V2. So, V1 only we have to identify. Usually, molarity only we use to identify what it is V1, what it is M1 V1 equal to M2 V2 in that way. N1 V1 plus N2 V2 in that way. So, this is somewhat different. I hope you got the clarity. Yes, come on, let's go to the next question. The next question, 1m HCl and 2m HCl are mixed in volume ratio 4:1. Now, what is the final molarity of HCl solution? See here, like a comparison way, both ratio and final molarity we have to identify. For that, we have to go for volume as well as mole to find out that final molarity. Right now, here, okay, volume in ratio, volume of 1m HCl and volume of 2m HCl. So, what is the ratio? It is 4:1. Right. Now, here, volume of 1m HCl, volume of 1m HCl, it is 4 volume. And the same way, volume of 2mHCl, it is what it is? 1. I hope you got the clarity. This point, which is related to this as well as this. Got it? Right. Now, here, total volume, total volume, how much? 4 volume plus 1 volume. So, you will get 5 volume, right? 5 volume. Total volume equal to 5 volume. Okay. Total volume equal to 5 volume, right? Remember this one. Next one, total moles we have to identify. Total moles. So moles, how to identify? Molarity into volume. Molarity into volume, how to identify? Here 1 mHCl into 4 volume. See, molarity into volume, right? So first one, what it is? 1. And the second one, what it is? 2m. 1 mHCl and 2 mHCl, right? 1 mHCl and 2 mHCl. So 1 mHCl into 4 volume. And the second one, 2 mHCl into 1 volume. So you will get how much here? 4, and here you will get what it is? 2. So altogether total moles, 6 moles. So you got it? Molarity into volume, 1 mHCl, 2 mHCl, 1 mHCl related 4 volume, 2 mHCl related 1 volume. So altogether you will get 6 moles. Now, finally, we are coming to that main answer. What it is? Molarity we have to identify. Molarity equal to, molarity of final, right? Final, because 1m, 2m, it has mentioned already. So this is the final. So here, what formula can we bring it here? Total moles divided by volume, total volume. Right, as total moles, how much? Here we brought it, no, total moles. Total moles equal to 6 moles. Total volume, how much? Total volume, it is 5. Total volume, it is 5. So what is the answer you will bring? 1.2 m. That's all. So molarity of this question, molarity equal to 1.2 m. I hope you got the clarity. How do we bring it? This is very simple, but looking at questions are more different, right? So yes, the questions are really amazing right now. So this is a molarity m. It has to be mentioned because molarity answer, or mole per liter. That is the way you can read. So 1.2 m. I hope you got a clear idea about all these questions, whatever we have gone through. And thank you for watching.